Hi everyone. In number 4, we have a really messy looking integral that we're going to try and use substitution on. And we're actually directed as to what substitution to do, and we're going to try 3 different substitutions and see what happens, see if they work or don't work. So in this first one, we're supposed to let our u represent just plain old e to the x. So if that is true, then du dx is going to be also e to the x, which means u is equal to e to the x dx, du is, sorry. And this is great, but recognize, this is where people can get into trouble, recognize that part of your substitution just showed back up in the derivative. So one thing you could say is that du is equal to u dx. So it's up to you, and in that case I'd probably group them together. So either way is fine. If I'm going to try and use this, that's great, but I need to look up here and say, okay, well then one of those e to the x's has to be replaced by a du. So we'll do this for number 1. And in number 1, I'd say, okay, well, I have e to the x, so I'm going to make this one a u, and e to the x, I'm going to make this one a u. But this pair right here is my du. So I'm left in the top with e to the u. In the bottom I have 1 plus e to the u. And then I have a du. And this is fine, and I do think it's a little bit simpler, but I'm only going to get out of this if I either get really fancy and use long division, which probably you don't want me to do, or if I do another substitution. So I could say w is 1 plus e to the u, which means dw du is just plain old e to the u. So I can replace e to the u du with dw. So here's my e to the u du. So that's going to become dw. And on the bottom, I have my w. So the antiderivative of 1 over w with respect to w, that's going to be natural log absolute value of w plus c. And then I'm going to have to work my way back out of a couple of substitutions. So that's natural log of the absolute value of 1 plus e to the u. And actually I can drop the absolute values on that because e to the u is never negative. It's not even 0. In fact, it's always positive. So either way, but I think I will. So I have natural log absolute value of 1 plus, oh, and then I kept it after all that. Let's get rid of it. E to the x plus c. And as always, you can take a derivative to check that. We're going to do this one a lot of different ways, so I think I'm just going to keep it. And if we start to see things not matching, I'll get worried. Okay, just so you can see what would happen if I did this, it's going to be very similar to. So instead of snagging that e to the x dx and making it my du, sometimes that's a little tricky for people to spot. They feel much better about just going in and saying, okay, e to the x is a u, e to the x is the same as e to the u. On the bottom, I have a 1 plus e to the u, and then I replace dx with du over u. So we will end up the same place, right? We'll cancel out the u's, and we still get e to the u over 1 plus e to the u du. So I'm not going to continue, I'm just going to give you an arrow, because from there it becomes the exact same work. So you do have some choices, and I would just base that on what looks easier to you. It's the same thing. So if you like to just name them all u's right away, my dog's attacking me, then name them all u's right away. If you like to not rearrange the u equals e to the x dx into u equals u dx, then don't do that. I don't know what I just said. Okay. Dog's not attacking me anymore. I should be able to think. So whichever way you like is fine. It was supposed to be the bottom line of all that confusion. Okay, so now we're going to do it again. Exact same problem, different substitution. So often there's more than one substitution that can work. And sometimes one's easier than the other, and sometimes it's not. So we're just going to compare here. So I'm going to rewrite my integral. I was looking for the integral of e to the x times e to the x over 1 plus e to the x. Now I have to go back and look. Yes, dx. And now we're told to snag this entire e to the x piece and make that our u. So our du dx, and this is where you really do need to know your Calc 1 shortcuts, not just because we're reversing them, because we use them here. E to a function is its own derivative multiplied by the derivative of the inner function. The derivative of the inner function, e to the x, is still e to the x. So now our du is equal to e to the x times e to the x dx. And again, you can do some rearranging if you want. This right here is a u. E to the x we're kind of stuck with unless we do a little solving. But you could solve that for dx and replace. I think what I'm going to do is say, erasing those, I have exactly that sitting here. So all of that becomes my du, and then on the bottom I have a 1 plus u. So this one I would leave up to you. It could still be a substitution. There is a little composition going on there, so this is like a 1 over 1 plus u. I know the antiderivative of 1 over x, so there is an extra plus 1 in there. That's a pretty simple function that I've got plugged in, an x plus 1 or a u plus 1 instead of an x. So if you feel comfortable, you can just go for it without the substitution. It is going to be a natural log, but if you're at all uncertain, because sometimes people go crazy with that and they do it when they shouldn't, we could come back over here and say, okay, just to be safe, I'm going to replace the 1 plus u's with w's, and that is an easy substitution because the derivative of w with respect to u is 1, which means dw and du are interchangeable. The substitution we're doing isn't messing with the widths of our rectangle, is one way to say that. Okay, so that, if you did that, would turn this into dw over w. And the antiderivative of that is the natural log of the absolute value of w plus c. And then I just have to work my way back out through some substitutions. So w was 1 plus u, and u 1 plus e to the x plus c. Okay, so we got all the way through. So let's compare notes. 1 plus e to the x plus c. It looks perfect. I didn't drop my absolute values this time, but you can if you would like to. So different methods, same result. I would say they're sort of comparable unless you felt comfortable enough skipping the second substitution. Then I guess this was a little quicker, but sort of comparable so far. Okay, so we have one more to do. So again, let me rewrite my function. Here, I'm going to switch colors. So we have an integral of e to the x times e to the x over 1 plus e to the x dx. Okay, and we are supposed to, this time, substitute out the entire denominator. So now my du dx, the derivative of my u with respect to its variable x, the derivative of 1 is 0, so actually it's the same as last time. E to a function's derivative is e to that function multiplied by the derivative of that function. So once again, e to the x times e to the x dx. I'm going to snag all of this, and I'm going to make it my, oops, let me see what I'm going to make it. It's going to be my du, and then my bottom is going to be u. So this one I actually do like a little better. That doesn't mean I would have been in trouble with the others. We made it, right? So I want you to be aware that while there can be more than one option, it doesn't mean that one option is necessarily bad and the other one is good. Sometimes one is easier, sometimes it doesn't really matter, sometimes you can't get through it if you don't do the right one. So just play around. Don't be afraid to try different things. So here I don't feel any need to go for another substitution. I can say straight away that's the natural log of the absolute value of u plus c, and I also only have to work my way back out of one substitution. U was 1 plus e to the x plus C, and that again matches what I got in the last two. So play around. It's okay and encouraged for you to do so. That's the only way you're going to learn what works and what doesn't. Thanks for watching.